Sorry, internet people. 0 3 tenths. Let's fix this. All right, so I think we have sound and video now. Okay, so back to this multiplication. Yeah, so the proper way would be to say 3 tenths times 4 tenths is a better way to read it. And again, we're used to our slang, but when we're teaching this to kids, we want to avoid slang and say it properly. Help emphasize place value. So the first interpretation would be 3 tenths groups of 4 tenths. And so we have to try to draw a picture of that. So we'll do that in just a second. Other way to view it is that we're doing an area, and these two end up being pretty, the same thing, where we have a length of 3 tenths and a width of 4 tenths. So we'll do a quick single-digit one, then we'll try a double-digit problem. So page, grid. And one thing that's helpful is if we know how many that is. Let's see. That big on the square. Get that right. Slipped a little bit. Let's double check it. So in order to show 3 tenths, I have to show what 1 whole is. And so from here over to here is going to be 1 whole. And so then I can have a base of 3 tenths. And then measuring up from here to here, there's my 1 whole, so that I can show 4 tenths. So that means I'm interested in this window right there. So what's the proper name for decimals? Anybody remember from last class? Decimal is kind of a short slang. Yeah, they're really decimal fractions. So we need to keep that in mind. So they're fractions where all the denominators are related to 10. Powers of 10. Okay, these are fractions. So in order to talk about a fraction, I need to want to know what a whole means. So what would a whole area be here? Remember, my interpretation here is area. Multiplication is area. So what's a whole area look like here?
A whole area that's shaded or overall?
Overall. What's a whole?
100 units.
100 units? So what's a unit? A unit is each one of these squares here?
Yes.
Yeah.
Okay, yeah, so this is 1 by 1, so this entire thing is 1 whole. And so then we just have to identify what part of that whole that we have. Well, that's not too bad. We know this grid is 3 by 4, and 3 times 4 is 12.
So we also do it as 3 over 10 times 4 over 10.
We could write it as fractions too. Yeah, we'll do that in a second. So I definitely have 12, and the question is 12 what? Each piece is what part of the whole? Say it in whole numbers, not point. How many pieces are in a whole?
100.
100, there we go, yeah. Because this, like Christian was saying, was 3 tenths, and this is 4 tenths, and 10 times 10 is 100. So we get 12 of this.
for the answer.
And so we discussed an algorithm last time. When you multiply two decimal fractions, oops, you can ignore the decimal point for a moment and say 3 times 4 is 12, but then you got to figure out where the decimal goes. And the rule is what?
For every number multiplies one place.
Yeah, for every place you have in the factors, you have to have a place in the answer. So that means the decimal point here has to go right there. I like to put a 0 in front to be clear. It's optional. If your students are messy, you might want to force that 0 point. And that most of the class would be messy. So again, we interpret multiplication as area. Decimals are really decimal fraction, which means we need to know what a whole means in terms of each factor. And we need to know what a whole means in terms of the area in order to interpret this. And so one thing you'll see in the curriculum is you'll have pages of 10 by 10 grids separated out. And you can use them to draw different areas and talk about what decimal fraction you have in each one of those. And that was, I think, like activity 1 that we worked on last time. All right, so here comes the more exciting part. So here we have a model, and that model led to an algorithm. 2-digit multiplications. And so to do the 2 digits, we can easily do stuff like 2.3 times 1.2. If we start trying to throw hundreds in there too, the pictures are impossible to draw. So we're still going to go with that area model. So that means I need to draw a base that represents 2.3. So I'm going to use my eraser measure, roughly. So that right there is what 2.3 is according to my ruler. And then I need to go a height of 1.2. So that's about 1. And there's my 1.2. So I just put a couple other measurements in here so we can keep track. That's 1, that's 1, that's 2. So we draw it. This should start to look familiar. So I want to know what this area is right there. And so to do that, I have to break out what a hole is. So keep in mind, if our linear measure is 1 there and 1 there, then the grid that those two make is 1 hole. So here's the 1 hole that I get to work with. Now I just have to figure out what everything else means. And so we have a few more divisions to make. I have to draw my 2/10 that way, my 3/10 this way. So if that is a hole, then what is that piece right there in that picture highlighted in blue? If yellow is a hole, it's that blue piece. 1/10. And what is that piece right there?
100.
And so now we should be able to look at the thing and come up with an answer. Now sometimes it's not going to be as straightforward, but this time it's not too bad. So let's see. We appear to have 2 holes, right? And then how many tenths do we have? Well, we have 1, 2, 3, 4, 5, 6, 7 tenths here. So I have 7 tenths, 2 holes. And then how many hundredths do we have? 3 by 2, so we have 6 hundredths. in our picture, and then we can pretty easily put that together. What's our answer going to be?
7.7.
2.76.
2.76. Okay, so the 2.76 is slang, but we have 2 wholes, 7/10, and 6/100. Or we could say it's 2 and 76/100. We could read it either way. Does this picture look familiar at all from your previous life?
Yes.
Okay.
Off the test.
What's that?
I said off the test.
Well, the last test we had our fraction one that was kind of like this, but this was multiplying 23 by 12 back in chapter 3 when we were doing just whole numbers.
Oh, yeah.
Same thing. Now here we don't have to do any trading in, but sometimes we do. Sometimes we have to trade in tenths for wholes and hundreds for tenths. We don't have to worry about that at the moment. We'll try that in a sec. All right, so I'm going to write this down just a slightly different way. So we're going to break down place value with kind of an algorithm. Questions on this so far? So we can pretty clearly see the 2 wholes, the 7/10, and the 6/100. And we don't have to do any trading in because we don't have more than 10 tenths or 10 hundredths. All right, so we want to take 2.3, and usually with multi-digit things, we like to stack them, right? And so I'm going to do an expanded multiplication on this. I'm not going to do the regular multiplication algorithm. And I'm going to start with the easiest thing to multiply, whole numbers. Do you agree whole numbers are the easiest thing to multiply?
Yes.
So to do that, I'm just going to say, well, 2 times 1 is just 2. And I'm going to put it there because it kind of lines up nice with the place values. And then, let's say I can move anywhere I want from there. I said that was 2 times 1. Maybe I'll take the 2 times the 0.2. So 2 times 1 is 2. 2 times 2 tenths. Let's see, that's 2 groups of 2 tenths. What is that all together?
4 tenths.
4 tenths. So I'm going to have 2 and 4 tenths. Agreed? And then we can go the other way. So I've taken this 2 and I've distributed it down to these 2 pieces. Next, I'll try moving over to the 3. And I think the 3 times 1 would be easier to do. So let's see, that's 1 whole here, right? And that's 3 tenths. So if I have one group of 3 tenths, how much do I have?
3 tenths.
3 tenths, yeah. I'm going to line that up with this one. That seems to make sense. Okay, here comes the harder part. I then need to take the 3 tenths times the 2 tenths. Well, that's kind of like the problem we did first today. So if I have, so I'm going to have a fraction of 2 tenths. I only want 3 tenths worth of that 2 tenths. How much will I end up with?
6 100ths.
6 100ths, yeah. So and I'm going to have 6 100ths. So that's an expanded way of looking at it.
I don't find it cute.
It's necessary.
It's kind of off. In a way, it's kind of awkward to see like that because you see the 2 going down, like we've always seen in expanded multiplication.
You have always seen, right?
Yes.
The people you're going to be showing this are new to it.
Right. But when we've usually seen, like, let's say, expanded notation in regular whole numbers,
Yeah.
they usually just go down a straight line. But with this, when a 3 tenths and a 2 tenths goes straight down, it really goes back past 1 0, or 0 past
We can, so you want to start here and multiply like that? We can certainly do it that way. We'll do it that way in a minute just for fun.
It's just,
Let's finish this. We're not done.
backwards.
We're not done. Okay, so let's see. I have my place values lined up, don't I? Okay. So what do I have all together? It looks like I have 2 and 7 tenths and 6 hundredths when we put it all together. Does this have any relationship to the picture we just drew? So let's take a look back at the picture. So here I have in blue 2 and 4 tenths. If I look back at the picture, what do I have? Let's see, 2 and 4 tenths right here. So there's the 2 and 4 tenths. Let's see, 3 tenths and 6 100ths. Where's that live in the picture?
Right.
The next vertical group right here. So you can choose to move through it any way you want, but you're always going to get groups like this. I chose to do the 2 times the 2 whole number 2 times the whole number 1 first because it's whole numbers are easier to work with. So let's try a different way just for fun. So we have 2.3 times 1.2, and we're going to multiply expanded. And Christian suggested starting with the 2 tenths times the 2 tenths times 3 tenths. So what is 2 tenths times 3 tenths?
It would be 6 100ths.
It'd be 6 100ths. And where do you want me to write that? Right underneath that?
Well, you can't write it like an
You write
unit.
it anywhere I want. Where do you suggest we write it?
Right, I guess.
Over to the right? Okay, look over here maybe? Okay. And then what should we do next? Maybe the 2 tenths times the 2 wholes? Okay, so what's 2 groups of 2 tenths give me?
4 tenths.
4 tenths, and maybe I can put that right over here. All right, what should I do next?
One times the.
Yeah, I'm gonna have to do a 1, and since we started with the 3, it makes sense, I think, to go with the 1 group of 3 tenths. Was that give me
3 tenths.
3 tenths?
Since it's just 1, wouldn't it be easier just to write it as 2 and 3 tenths as a whole going down?
Is that gonna be obvious to someone that's doing this for the first time?
Maybe not.
So I just want to continue with the same distribution pattern, and then I take 1 times 2, and that gives me 2. Where should I put that?
To the left.
To the left over here. And then we've done it so things line up again, and it looks like things line up quite nice. There's the 2 and 7, 6. Let's see, it looks pretty different than this right here. Same numbers, different orientation. Let's double check. How does it relate to the picture we drew? So I'm going to look in the picture, see if I can find 4 tenths and 6 hundredths. Let's see, 4 tenths and 6 hundredths. Where does that live here?
Top rows.
At the top row, isn't it? There's the 4 tenths and the 6 hundredths over there. So let's use, I'm running out of colors to use on this.
Orange.
Can I get a highlighter? Oh, many colors. Orange, okay. So there's that. And then the other one was what, the 2 wholes and the 3 tenths, and that's this guy right here. So depending on where you start doing your expansion, you could be looking at 2 columns or 2 rows in the picture. But the thing we're trying to do here is we're trying to connect the idea of place value to the algorithm that we're using. Okay, so I'm going to stop here and pause the video because I want